Hi everyone. Let's start. We are in the second week of the semester. In our logic class, very exciting stuff happening today. We're going to continue studying true functional logic and we'll get deep into it. Okay. So the plan following the textbook is that we will learn more about the true functional logic grammar, the difference between atomic sentences, something that we've seen, and the 5 connectives, something new. Then we'll talk a little bit about the distinction between use and mention in philosophy, and we'll go into the syntax of true functional logic. For those of you who have been to the tutorial, what is I take to be the main lesson from our tutorial in Thursday is that it's sometimes easier to think about, when you think about the notion of validity, sometimes think about kind of like the opposite notion of invalidity, and then work in steps. So to show that an argument is invalid, I have to have at least one situation in which all the premises are true, and immediately, if you cannot do that, the argument is going to be valid. And the conclusion is false. And if you cannot do that together with one, then again the argument is valid. This is kind of it's the same definition, but we're kind of following a procedure that makes it easier to detect validity and invalidity. Question, yeah.
So is it then that all arguments with jointly inconsistent premises are automatically valid?
Automatically?
Valid?
Valid, right, yeah, correct. That's a good observation, which is so nice. It has a name called the principle of explosion. Argument with inconsistent premises are automatically valid. Yeah. So what we do is like we try to show that it's invalid. We go to one. We try to show a situation where all the premises are true. Impossible because they're inconsistent. So we kind of like exit and say, it's valid. Okay. And that was also part of the homework one. The homework one was homework one was due today. Did anyone have any issues with like submitting it? No issues with submission. Okay, so we will grade it soon. You'll have nothing too surprising. The score of like we just checked that you've done it. Okay, you already have the answers. Okay, other questions about the homework? Okay, so let's jump into the grammar of true functional logic. So this is something that we've seen last time. Atomic sentences are the building blocks out of which all other more complex sentences are built in true functional logic, and we will see more of this today. They can stand alone. A, just stands alone, atomic sentence. Or they can be a sub-sentence of something bigger, A or B. We will see how to think about order. Symbolized with capital letters. And sometimes we can choose A, B, C. Sometimes we can just give them numbers. As long as these capital letters and it's understood that these are atomic sentences, it's all good. Okay, and this is how we translate English to functional logic. The first step is to figure out what are the atomic sentences of English and then give them a letter, which gives us a symbolization key. Okay, any questions about symbolization key or atomic sentences? Right? Okay. Sometimes it requires a bit of practice to recognize what in English, what would count as an atomic sentence. But that's kind of a practice that we get along the way. Okay, now this is a lot of new stuff that we will cover today, a lot of new symbols and a lot of new names. We have in true functional logic 5 connectives. These are called connectives because they connect sub-sentences, like atomic sentences of true functional logic. And with them we build more complex sentences. Okay, so we will cover today the negation, the conjunction, the disjunction, the conditional, and the biconditional. They have this cool symbol. Okay. Part of your work as like practicing learning a new language is that you need to kind of remember this wedge and the upside down wedge, they have different meanings, this one goes with that, this one goes with that, right? The conditional is kind of nice, just if then. Okay, but we will get there. I'm just flagging that like at the first, probably in the first few times you practice that, you will kind of forget which symbol goes with what. But that's kind of the practice. Okay, what do they mean? Let's start with negation. So let's say I have an atomic sentence, Rex is a cat. I can negate a sentence, right? This is something we can do in language. I can say, Rex is not a cat. And then I have a negated sentence. We already kind of saw it in the examples of arguments in English, and sometimes there is like this like not jumping into the picture, right? So this is negation. It's actually in true functional logic to make things very, very clear and easy. Whenever you see negation, the best way to read it is, it is not the case that blah, blah, blah. So if our sentence is Rex is a cat, then to negate it, we read it as, it is not the case that Rex is a cat. And we formalize it with this line here, which we call negation. Okay, so this is the symbol for negation, not A. Okay, or not fancy A is kind of, in general, the way to negate any sentence, and we read that it's not the case. Okay? Negation is tricky, and in natural languages, so if you're a linguist, you kind of study how negation is more interesting than it first looks. Note that in English, Amanda is unhappy. Amanda is happy. How would you negate it? You might think Amanda is unhappy. Kind of like negated, the kind that you happy. But this is not exactly right, because being happy and unhappy are not exhaustive in the sense that you can be kind of just asleep or something, in which you're not happy and you're not unhappy. So the negation of Amanda is happy is better to, again, say it's not the case that Amanda is happy. Okay? Instead of including the negation in the word. So this is the way to make it the most clear. And this, by the way, also happens with people talk about believing stuff. So you say, I don't believe that I'll catch the train. And this means that I believe that I won't catch the train, right? As opposed to, I don't know if I'll catch the train. This does not mean I know that I will not catch it. So sometimes English plays these tricks on us with negations, and it's always the best thing to do is to add this like it is not the case in order to make the negation very, very clear. Negation is our easiest connective because it only applies to one thing. You take a sentence, you negate it, you get a new sentence. The rest of our connectives connect two different sentences. So we start with conjunction. If I have two atomic sentences, okay, the dog and Lekia is a dog, V and J, I can conjoin them to get a new sentence, Joke is a dog and Black is a dog. And we write it down as J conjunction V. Okay? And we put parentheses. And there is some terminology here. When we have a sentence like J and V or J conjunction V, we call each part of the conjunction a conjunct. Okay? A new word that people don't often use outside of linguistics and philosophy. But now J is one of the conjuncts of the conjunction J and V. So that's a fancy word. It's also important when we go deeper into the logic. And negation and conjunction can come in English in many words, not only and is the most obvious one. So Nathan is smart and handsome. That's an example of conjunction. But I can also say Belt and Willem are both stylish. Okay, that's kind of tricky. I mean, I'm saying Bert is stylish and Willem is stylish. Okay. So this sentence also involves a conjunction. Although who is tall, he is not a basketball player. Although here basically also has the function of a conjunction, right? I'm saying another way to say the sentence is who is tall and he is not a basketball player. Now you might say, wait, although has more kind of meaning to it. It kind of indicates some kind of a conflict or difference. That's true, but in true functional logic, we kind of ignore these intricacies of English or other languages, and we just take it to mean a conjunction. Another word in English that takes this world is but. So Byron is good at squash, but Alfred is better. This is a conjunction. Byron is good at squash, and Alfred is better than Byron. Yeah.
Those last two sentences are different from the first two, right? Or would you write it the same in the TFL language?
Yeah, so all of them you would break down into atomic sentences, and you will write it down as a conjunction of two atomic sentences.
Okay,
With the exception of the last one where this is not something for true functional logic yet. Because it refers back to Byron, yeah, so it's kind of a more complicated sentence. Yeah.
For the third sentence, we have to use negation. We translate it to conjunction.
You're thinking here?
Yeah, so it's like a.
Right, yeah. Good. You're better logician than I am. I forgot. There is a not here, so not indicates negation. So if you break it down into atomic sentences, you'll have who is a basketball player. It's not the case who is the basketball player and who is tall. This is how you will break it down. Yeah.
But if you create an atomic sentence yourself, you could say that atomic sentence is who is not a basketball player.
Okay, good. That's a good point. We always, when we create atomic sentences, we make sure that they don't include any of the connectors, including negation. This is just like a best practice to figure out what is the form. Okay, so if you see a sentence in English with the word not, you should say to yourself, this already is not an atomic sentence. I have some atomic sentence and I will add negation and then I'll get that sentence. That's a very good point. So when you create atomic sentences, always make sure that the atomic sentences don't have negation or conjunction or all these stuff. And then you build them up. Okay? This is how you squeeze the most out of the structure of the English. We'll see more about that. Okay, good questions. And also, conjunction had there's a lot of in English in natural languages, the word "and" usually have a lot of meanings beyond just conjoining two sentences. But in true functional logic, it just means this is true and this is true. Okay, sometimes in English people use it as to indicate order of things. Like, they got married and had a child versus they had a child and got married, somehow implying that there's an order to things. But this is not the same. In true functional logic, we don't build these assumptions. It's just like both of these things are true, the order doesn't matter. Okay. Now we already have negation and conjunction. We can play around with them. We get a lot of things just with that. And so here we have kind of how would we formalize these sentences. Nathan is smart and handsome, S and H. Bert and Willem on both sides, P1 and P2. And again, choosing the numbering or the letters doesn't really matter. Although who is told he's not a basketball player, T and not E, as you indicated there's negation.
Yeah, you just said that for conjunction we have to use brackets or parentheses. Why?
So we will see the strict rules is that whenever you use a conjunction, you add parentheses. Here you see that we don't have that, right? This is because we have kind of a lazy convention that we can drop the outermost parentheses. Okay, but once we have more and more connectives, it's very important to keep at least the inner parentheses. Bind is good at cost, but Alfred is better, so G and B if you break it down to atomic sense. So here it says Alfred is better than Bind in squash. That would be taken as an atomic sense. Yeah.
Well, what is the difference between the normal letters and the P1?
No difference. It's just like a matter of what is easier conjunction. Sometimes, in a very fun situation, you might want to have a lot of atomic sentences, and the Latin alphabet restricts you. If you want 100 atomic sentences, then you will go with the numbering, right? Because then you have many options. Okay. Okay, so this structure A and B, or A conjunction B, paraphrase the English phrases both and, but, although. Okay? These are all conjunctions in English. Okay? Questions? Disjunction is kind of like the cousin of conjunction. They interact in very interesting ways together. Disjunction just basically captures order. Yeah?
Could you go back to the next slide?
The previous one?
Yeah, the previous one, sorry.
Yep.
Isn't it a little bit confusing because in English both and but although are like they mean something different.
Yeah.
Right? Why
Yeah.
is it the same symbol?
So good. So each one of them, you use them differently in English because they have extra meaning beyond just like this is true and this is true. They indicate usually like some kind of contrast. But this is an important point to understand is that true functional logic, when you move from English to true functional logic, you lose a lot of subtleties of English or other natural languages, and you kind of stay with the bare bone. Okay? And if you think what they do have something in common, all these phrases, that they kind of say this is the case and this is the case.
Yeah.
So this is the only thing we care about when we think about conjunctions in true functional logic. Yeah? Okay, so the disjunction happens when we have the word or. Oh. Right? The, either Amanda will take a nap or she will come to the party. Okay, so we write it down as N or P. This is not V, okay? This is not the letter V anymore. This is like the sign for disjunction or. Either this is the case or that is the case. And like with conjuncts and conjunction, now we have disjunct or disjunction. So and P are the disjunct that make the disjunction. So we call each part of disjunct. Fun name. Okay? Another example, either Alf or Ru will play football with me. We translated that as A or H. So the idea is that now we say Alf will play football with me, Ru will play football with me, and the way I'm building the disjunction is it's either the case Alf will play football with me, or it's the case that Ru will play football with me, which has the same meaning. Yep.
But do you always need to use the something more so the brackets?
So the brackets, the parentheses behind.
Yes.
So as I said, like the strict rule is that whenever when you describe a disjunction or a conjunction, then you should put parentheses around them.
Always?
Yeah, that's kind of like if you want to be sure, you can always use them. It's just like the convention is that whenever it's like the outermost one, kind of like we're at the end of the sentence on both sides, then we can drop. But if you want to be super clear about it, then you can always put the parentheses. Okay, but here we don't because it's kind of like simple, not structured. Okay. Yeah, yeah.
No,
Your computer had a question.
Sorry.
Okay, disjunctions are a bit more complicated than conjunctions. Yeah, you had a question.
Yeah, I was still about the previous slide.
Yeah,
I was struggling with the exercises with neither and more.
right. That's more complicated. That's a combination of negation and disjunction. So we will see how to formalize that and what the exact meaning of neither nor is. Disjunctions come in two flavors. There's what is called exclusive or exclusive disjunction, and the inclusive or, the inclusive disjunction. The exclusive or excludes the possibility that both disjuncts are true. So in the wild, when you use English and other natural languages, oftentimes people actually mean exclusive or. And so when people say menu deal includes appetizer or dessert, it usually means you have to pick either one, but you won't get both, right? Or you'll get coffee or tea. Sometimes it means you'll get one. Okay, so sometimes people use the or in this exclusive sense, saying that it's not possible for both of the things to be true. And inclusive or does allow for both disjuncts to be true. And so when I say either Alf or Ru will play football with me, and I mean the inclusive or, then I also mean that it's possible. I'm not ruling out the possibility that they both play. Okay? This is different than you will either get an appetizer or dessert. Exclusive or says, by the way, you won't get both. Inclusive or, who or Alfred will play with me, says it might be the case that both of them will play with me. Okay? And for us, disjunction is the inclusive or, the inclusive disjunction. Okay? And so this is kind of like just to have a starting point, to simplify things. This V, this disjunction, is going to be read as the inclusive or. Okay. Question about disjunctions? Yeah.
Just in regular English, the exclusive or is used more regularly.
It's hard to kind of like just say it. It's a very difficult question to estimate.
Most people that use the word or mean that it's either one.
Yeah, it depends. It depends on the situation, so it's very hard to quantify. People just use it in different ways, and sometimes there is kind of like, yeah, it depends. It very much depends on the situation, and yeah, these are difficult words, more difficult than they seem.
With the inquisitive, is with like conjunctive validity, is that a consideration when we're doing like, is that they're separate topics to this sort of language?
Conjunctive validity.
I mean, what's it? Validity of two sentences combined.
So validity is a relationship between sentences and a conclusion, right? Between premises and conclusion, and these sentences can involve in conjunction, disjunctions, negation, all the bunch. So we will see in the next 2 lectures how these connectives are connected to validity. That's kind of like the heart, in a way, of true functional logic. But now we just want to understand what they mean. Yeah.
If you wanted to make a sentence in an exclusive order, how would you do that?
In English or in true functional logic? And we will see, but we'll see very soon. It can be done. It's actually, we already have the resources, so to speak. We want to say A or B, and we want to add the constraint that not both. So we can say, and it's not the case that A and B. Okay, so we will see it very soon. And so now we have conjunction, disjunction, and negation. We can combine them, and doing that is already a lot of logic to it. And so I can say it's not the case that both Hoop and Alpha will play. It's not the case, negation, that both Hoop and Alpha will play. So I know I have negation somewhere here and I have a conjunction somewhere. But the way we order them matters, right? This is where the parentheses become important. So first I know that I can say Hoop will play and Alpha will play. That's a conjunction, right? I can write it down as H and A. So where would I put the negation now to get the sentence we started with? Yeah, so outside of the entire conjunction. Now I negated the entire conjunction. I negated the claim that Hoop and Alfred will play with me. Okay. Now compare that to Hoop will not play, but Alfred will. Okay, so first in English, what connectives do we notice that are in play here? Just shout them. Negation, right? Negation and conjunction. Okay, I know that there are negation and conjunction involved here. The question is how exactly. So the but is the conjunction, not is the negation. Okay. So what do you think? How is that going to be expressed?
Negation H, conjunction A.
Yes. So negation H, conjunction A. Now this is where now we're starting to get a feel why the parentheses are important. Because here I'm indicating that the negation applies to everything inside the parentheses. Right? And here, because there is no parentheses next to the negation, I know it applies to the immediate sentence here, H. Okay, these two sentences and mean different things. Okay. Yeah.
And would you also say you will not play and Alfred will play? Or is that different?
That's the same as this line. Who will not play? And in terms of like true functional logic, these are the same sentences. Treat them the same. Yeah.
Oh, no.
Okay. Let's see. Yeah. We note that like already with like conjunction, disjunctions, and negation, I'm get scared because a lot of things can happen with these three things. Okay. So how, like, what the negation applies to is called the scope of the negation. Okay, you can imagine like asking yourself, what does the negation capture? What does it apply to? What is its scope? So in this example, the scope of the negation is only one conjunct, H. And in this example, the scope of the negation is the entire conjunction. Okay? Yeah.
I do have a question about the first one. Does it not now say it is not the case that root will play, and it's not the case that alpha will play?
No, so that's a different sentence. You're saying, you're thinking about the sentence. It's not the case of who will play, and it's not the case of the alpha, right? What this sentence says is that it's just, we rule out the possibility that they both play together. So it still can be true that who plays if it just means that it's not the case of both. And this says none of them is going to play with it. Okay? That's kind of like the intricacies here. Yeah.
In the last situation, would you call that like a wide scope negation, or is it two single scope? No,
Two single scope. Okay. Yeah. So this negation applies only here, and this negation applies only here. One way, it's also like if you want to practice this a bit, you can take something to mark on, and just like you can kind of like mark how long the negation applies to. So like in the sentence H of A, H and A, not H and A, I can say, the negation kind of applies all the way here. And here it applies only here. Yeah.
Could you state the first, the one you just written down? Could you state that as either root will play or alpha will play?
But not both, right?
Yeah, because
So, but not exactly, because we get kind of ahead of ourselves, but it's okay. So this says it's not the case that both Hupen and alpha will play. So we're ruling out the possibility that we'll see both of them in the courtyard, whatever. But it's still possible that we'll see none of them, or one of them, or the other one. So it's still possible we'll see none of them. We just ruled out the possibility that both of them will be there. Okay? Either you will not have dessert or not an appetizer. Okay, so what do we have here? Just look, scanning the sentence, we have what connectors in play. Disjunction and negation, right? Now, if D is you have a dessert and A you have an appetizer, how do we symbolize this entire sentence? What do you think? Yeah.
I think we use a wide negation scope, or so negation, then the open bracket is D or A.
D or A. Okay, so this is tricky a bit. Just for now, try to follow the English. Note that like the either or is built up out of two other sentences. You will not have dessert, and the other sentence is like not an appetite. That's actually not a full sentence, but that's kind of like the component, right? And each one of them is negated. And so the scope of the negation is on which each one of them. Okay. Now we're getting more complicated. We have neither coffee nor tea. Okay, so first of all, I didn't tell you what nor or neither. They didn't show up, right? So this is something new. But let's just try to think, what does it mean in terms of what am I saying when I say I neither have coffee nor do I have tea? Both not, right? I don't have, like, I'm telling you, I don't have the coffee and I don't have the tea, right? I'm kind of ruling out all of these possibilities. And so, in fact, there are two ways of formalizing this. One way of thinking about it is to say, I start with the sentence, you either have coffee or tea, and I'm negating that. It's not true that I have either coffee or tea, meaning that I don't have coffee and I don't have tea. Logic is nice because if this confuses you a bit, it's okay also to read this as saying, I don't have coffee and I don't have tea. And what is the relationship between this and this? This is a topic that we will learn soon in the next lectures. But for now, think about what does it mean to say we have neither coffee nor tea. I'm saying it's not true that I have any of those. Right? So I'm saying it's not the case that I have either coffee or tea.
It would also apply to the group and some of
Correct, yeah. So and there is a pattern here which will apply as well. The pattern is famous, so famous it has a name. So we will get to it later. But for now, it's kind of like important to understand. Okay, this has kind of like a truth functional logic structure to the neither. Okay. So one way to remember it is to negate a disjunction when you say neither. Negate the disjunction. Negate the neither. Okay. Now, if someone says that you will have either beer or a mixed drink, but not both. So remember, we talked about exclusive or inclusive or. When we say kind of not both, what do we indicate? It's an exclusive or in English, right? I'm saying you either have this or that, but not both. But I haven't taught you what is the symbol for an exclusive or, right? I said that this nice symbol always means an inclusive or. So how do you get to formalize or symbolize an exclusive or like this? Any ideas? Yeah?
I'm not sure, but it could be that first you put brackets, and then you do not do the word and then you close brackets, and then that's one part.
Not the and.
Or wait, and.
But wait, you say you have a beer, right? You can either have one of them.
Yeah, so. No.
One thing that we know is like talking about this in English is even kind of hard because you can have to say negation, scope, yeah, right. So this is why we have logic to make life easy.
I think it's like negation, and then you put the brackets, and then the and then the conjunction symbol, and then maybe the close
Like this.
Yeah.
So this says it's not true that you will either have a beer or
Oh no,
a mixed drink.
the other,
The conjunction.
yeah.
Yeah, that's okay. So that's part of the sentence. It says it's not true that you will have both. And then we have, I guess, other people want to indicate that there is another part to it. It also says it's not true that you will have both here, but we're also saying you will have either one of them. Okay, so I'm saying you will either have beer or a mixed drink, and I'm adding the information that it's not true that you will have both. Okay, so now we have a way to write down the exclusive or using the disjunction, negation, and conjunction. Okay. Logic is fine.
Isn't it just easier to say not there and mix?
Not beer and a mix.
Yeah, just the final part. Isn't it easier than including the
So this says you will not have a beer.
No, with the final part of the exclusive statement.
This part,
Yeah, just that part.
because this means that you will definitely have a mix there, a mixture.
It says you don't have beer and the mix. Right?
Right. So this and this are different, right?
Yeah, but I'm not talking about the
Okay, so
I'm talking about the just that statement that's already excludes the both.
this part.
No, I'm just saying why add the B or M? You can just drop that, right?
No, because you can this by itself is impossible that you don't have any of them. You don't have beer and you don't drink alcohol at all, so you don't have both. This says that you will have one of them, and this says you will not have both. So this kind of says you will not have both, but you will at least have one. So this kind
you will
of
have either, but you won't have neither.
I'm confused. English is this is why I like logic. Okay? It says one of them, but not both. If you take out the one of them, it's still possible that you don't have any of them, and that's also not having both. A way of not having any.
Could you write the first sentence with dessert in the same way? Because you're given the same option, right? It's
Yeah, so it's not true that you will have both, right? That's kind of a way of thinking. Yeah, so it is a way, but the first sentence, if we read the or as an inclusive or, it's still possible that you will have neither. You will not have a dessert and you will not have an apple. Okay, so this is why it's an inclusive or. Yeah.
Isn't it in the last sentence also possible to have neither in neither?
No, because for this says that one of them has to be true.
Yeah, but the English sentence itself, it doesn't explicitly say that you
Yeah, this is
have.
it's kind of like up for us to like you can say you'll have either beer or mixed drink, and it's kind of like saying about the future that one of them will be true. But again, this is like English is difficult, and so this is one way of reading it. Yeah.
I think I don't understand fully the exclusive order because I would just write the disjunction and
Right.
and then it would say you'll have either beer or mixed drink.
Okay, so remember.
So why does the word either not signal that you'll have one or the other, not both?
It's just like English doesn't have these strict rules. You can use words in English kind of like in many different ways. So there is no rule in English or in Dutch that either always go with inclusive or inclusive. People just use it in different ways. You can make the English very explicit by adding the extra condition. And so I cannot tell you that in English, whenever an either appears, it must be an inclusive or exclusive. People are, it's not your daddy's language. So you can use it however you want, right? But logic, you can. Other questions? This is complicated. Or more questions? Are we ready for even a more annoying connective? One more connective and then we take a break. The conditional, okay? This is the arrow. Conditional shows up in English or in natural language when you have phrases like if then. Okay? If Amanda is in Tilburg, then she's in the Netherlands. Okay, so this example of me interpreting in the Netherlands, it's the one that we like to use. Okay, so we have T and N, and we write it down as T arrow N. If T is true, then N is true. If you're in Tilburg, then you're in the Netherlands. Remember that for disjunctions, we have disjuncts making the disjunctions, and for conjunctions, we have conjuncts making the conjunctions. For a conditional, we have a different set of phrases. We say that T is the antecedent of the conditional, and N is the consequent of the conditional. Antecedent, first part, consequent, last part. Yeah.
Maybe I'm getting into something, but just to be sure that this applies to all conditionals. So you zero, first, second, third conditional in English, but that's all just different forms of if then. So it's always this.
Always if then is a conditional with like an antecedent and a consequent. The antecedent and the consequent can themselves have a negation or conjunction because they are sentences of themselves.
So it doesn't change it instead of if Amanda is in Tilburg, Amanda would be in the Netherlands.
Right, that's a good point. For true functional logic, it doesn't matter. We only care about the if then would have been, it still will account for it. We'll just put it as an arrow still. Yeah.
If you switch the sentences around, does it mean the same thing or not?
No, it does not mean the same thing anymore. So, in fact, like if I'm in Tilburg, then I'm in the Netherlands, that's true. But if I switch the order, if I'm in the Netherlands, then I'm in Tilburg, that's false. Right? So this indicates that the ordering is important when it comes to conditional, and this is why the conditional is more confusing than the conjunctions and disjunctions. Because the conjunction and disjunctions, the ordering actually did not matter to us. Okay. Only if is another expression that involves if showing up in English. I put this like nice emoji to tell you this is confusing to me. When you see only if, you also need to phrase it with a conditional, but the question is in what order? That's the hard question. And think about the sentence. Amanda is in Tilburg only if she's in the Netherlands. Is that correct? Right? That's correct. We agree? If you're in Tilburg, then the only way to be in Tilburg is being in the Netherlands.
If there's one Tilburg.
Dude, of course. The one and only. Okay, so let's say we want to formalize this sentence and we have these two options, right? These are the only two options. We either put the T arrow N or N arrow T. And we're saying this kind of express something which is actually true. So how would you pick which one of them you would pick? The first one. Yeah. So I suppose this is what will show up. Okay. Now this is a bit confusing. Basically, we need to remember when we're saying only if, the expression coming after the only if will take the place of the consequent. Okay. She's in the Netherlands. I need to put it in the consequent if it comes after the only if. Okay, that's kind of the rule here. Okay. So just like we kind of to summarize, the sentence can be symbolized as if A then B, if it can be paraphrased with English, if A then B, or A only if B. Okay? You see these things? When you have if A then B, that's easy, you know A comes first, then antecedent B comes later. And the rule for only if is to remember that whatever comes after the only if, that's going to be in the constant, and the rest in the antecedent. Okay, and as we said, the order is important. You can have a sense like, if you have oxygen, then something will burn. In the presence of oxidants, guarantees the match is going to be burning. Or you can flip the order to get something else. You say, if you have a match burning, then you have oxygen. And for the chemistry aficionados in the room, what is the correct one in the actual? The last one, right? So like you have to have oxygen in order to have burning, but hopefully, like, good for us. Just the presence of oxygen would not suffice for burning the development in a big fire. Okay, so this shows you that it's important. The ordering is important, but it also shows you that kind of like the oxygen is the requirement for burning. Whatever comes in the consequent kind of expresses what is required for a thing to happen, and whatever comes in the antecedent represents what is like sufficient for the burning. So if you have, it's sufficient for a burning that you have oxygen. Okay. Let's take a break. Come back at 46. Okay, back to the famous conditional of true functional logic. There's some terminology involved with the conditional I want to talk about. So there are many ways to express something like, if Amanda is in Tilburg, then she's in the Netherlands, which all boils down to, if Tilburg, then the Netherlands. I'm choosing also in particular a conditional which is actually true. So it's easier to think about it. And people talk in terms about necessary and sufficient conditions in everyday life and in logic. These terms are quite confusing, so it's worth thinking about them at the moment. If T then N is true, it's also the same as saying, for Amanda to be in Tilburg, it is necessary that she's in the Netherlands. Right? If you're in Tilburg, then necessarily you're also in the Netherlands. So if you look at this, if T then N, you can say that the necessary condition for being in Tilburg, for the antecedent to be true, is expressed in that consequent. And I would say it is a necessary condition on Amanda being in Tilburg that she's in the Netherlands. Okay, that's the necessary condition for being in Tilburg. There is also the talk about sufficiency. For Amanda to be in the Netherlands, it is sufficient that she be in Tilburg. So another way to think about it, the sentence expressed in the antecedent, being in Tilburg, describes a sufficient condition for being in the Netherlands. Okay? It is sufficient that you're in Tilburg to be in the Netherlands. Because if you're in Tilburg, okay, it's enough to decide that you're in the Netherlands. Okay? This is confusing because when you formalize a conditional, you need to make sure you do it in the right order. And here you have all these like various ways of putting this structure. Okay, so one way to remember it is that once you have a conditional, the consequent describes the necessary condition that has to be true if this is true. And this describes the sufficient condition for this. Okay? It suffices that you're in Tilburg, it's enough that you're in Tilburg in order to be in the Netherlands. Okay? And as I said, whatever comes after the only if describes the necessary condition. So this is how we can come back to the only if, and the necessary condition takes this consequence place. So I say A only if B. I'm saying B necessarily has to be the case if A is the case. Therefore, B takes the consequent place. Yep.
And if you say A if B, does it then get reversed?
No, so when you say, this is the simplest way to say it, so to speak in English and true functional logic where there is no ambiguity. If A, then B will just be A arrow B.
No, not that. Just A if B.
Ah, okay, A is B. Okay, yeah. Whatever comes after the if is going to be the antecedent.
So it stays the same.
So this will be sorry, it will be if B arrow A, because whatever comes after the if captures the antecedent.
So it gets reversed.
Yep. Yeah. And again, I mean, the Netherlands, if I'm in Tilburg, something like this will help. Kind of like, this is an example which is easy to play with. Okay, after the mountain of the conditional, we get to a simpler and connected, the last one called the biconditional. As we used this example in the past, the word bachelor. So if we have the sentence B, the Pope is a bachelor, M, the Pope is an unmarried male. Suppose these are two atomic sentences. And although M is not really an atomic sentence because it involves un, so that's negation. But whatever, just for now, let's take it to be our two building blocks. The Pope is a bachelor only if he's an unmarried male. Okay, so the only if is the tricky part. What did we say? Only if B, the B comes as the consequent, right? So the unmarried male will take the consequent place. Is that clear? Okay, so the sentence, the Pope is a bachelor only if he's an unmarried male, will become into if B, then M.
But what's the concrete, what do you call it, difference between biconditional and conditional?
The biconditional says that both direction of the arrow hold, so to speak. In the case where the order, a way to think about it, in the case where the order doesn't matter, then it's a biconditional. And it's expressed with this expression if and only if, capturing the idea that you have two conditional statements together with a conjunction. Okay, so we'll see that here as well. So now I take the sentence, the Pope is a bachelor if he's an unmarried male. And as you said, whatever comes after the if, that will be the antecedent. So now The M will take the antecedent part, and you have this. Biconditional says if and only if both these things together. So there's one way of doing it would be just to write down like this, right? I can say if B then M, and if M then B. Okay, so that will be to say someone is a bachelor if and only if there are unmarried men. Okay, but we don't use this. We have actually a special symbol, because it's a nice symbol, to express the biconditional, with basically an arrow that goes into both directions. Basically saying, this is true, whenever this is true, this is also true. And whenever this is true, this is also true. Okay? Is this clear? How do you call Tilburg when in the carnival time? Kalverstad. Okay, so I don't know how to pronounce it correctly, but you can say you're in Tilburg if and only if you're in Kalverstad. Because these express the same thing, right? This is different than if you're in Tilburg, then you're in the Netherlands, because you can be in the Netherlands, not in Tilburg. But if you're in Kalverstad, then you're in Tilburg and vice versa. Okay? Biconditional, both direction of the arrow. Okay, and by the way, we often abbreviate the biconditional if and only if with this term, IFF. It's kind of like, if you see that anywhere, this is not a typo, sometimes it is, but in logic this is not a typo, this means if and only if, or biconditional. Okay? The biconditional in a way is easy because the order, if we're actually having a biconditional here, then the order doesn't matter. Okay? Another example from your life, you will pass the course if and only if you will get a high enough aggregated score, right? So if you pass the course, it means that you had a high enough aggregated score. And also, if you had a high enough aggregate score, then it means you passed. Okay. One very tricky, this is annoyingly tricky example, the word unless. This is mentioned in the textbook. I'll go it very quickly because we'll just say how we treat it. Unless it's one of these like English expressions which is very tricky. Unless you wear a jacket, you will get a cold. You will get a cold unless you wear a jacket. So, okay, we have two atomic sentences here, wearing a jacket and having a cold, and the not, right? And somehow in the un. So how do we paraphrase that into functional logic? The way we do it is as a disjunction in this course. Unless A, then B, we will just say, for now, it's a disjunction. If you see it in the homework assessment, treat it as a disjunction. Basically saying, it's not the case, like you either catch a cold or you will wear a jacket. This is how we understand the unless. We rule out the possibility that you don't catch a cold and you don't wear a jacket. Yeah.
This is the inclusive part.
Yeah.
But it can be true at the same time. You can wear a jacket and catch a cold.
Right. So the textbook goes into that like there's a big ambiguity with unless, whether it's like sometimes we read it as an inclusive, certainly exclusive. So just as a matter of like simplicity for this course, we'll treat it as inclusive. It doesn't really play a big role apart from in the exercise. Yeah.
I read this more as if you don't wear a jacket, then you will catch a cold. So as a conditional.
Yeah. If not J, why is B? Yeah, the added type of this should be a C. So you're saying if not J, then D, something?
Yeah.
Yeah, so keep that in mind because we will see what is the relationship later in the course between these two expressions. They turn out to be, they have a special connection.
So if in the exercise I have, if not J, then this instead of the or, I could count that still as right, or, because I know that the book will always say
Yeah.
or.
You can write both of them.
Okay.
Okay? But this is not like a real connective, it's just like showing that sometimes English has this like logical structure which kind of like challenges us as to how to write it down exactly. Okay? So take a break with the connectives and we move to this distinction between use and mention, which is important to kind of like get things clear. So to understand this distinction, we can see sentences like this. Michael is a philosophy teacher, and Michael in quotation mark is a philosophy teacher. Compare that to Michael is composed of 7 letters, and quotation mark Michael is composed of seven letters. Okay, the idea is that sentences 1 and 4 are true. If I think about the name Michael, 7 letters. If I think about Michael, this is me, and I'm a philosophy teacher. And these sentences don't really make very much sense. Okay? What is going on here? When we want to talk about me and my property, like being a philosophy teacher, we use the name Michael. And then when we use the name, it refers to me, and you can say things about me, or about you, depending on your name. And when we want to talk about part of the language, we want to talk about the name, describe properties of the name, we mention the name. So this is the distinction between use and mention. And we follow a convention in the last slide that when we mention a word, we use the quotation marks, and when we use the word, we just use it regularly. Okay? This is the beginning of the month, not the beginning of the war. Okay. So another way to think about it is oftentimes we talk about the world, right? We talk about Michael, I'm talking about myself in the world, being a philosopher. Sometimes we want to talk about language, right? And when we talk about language or about words, we want to mention or pick up the words, and we do that using quotation marks. Yeah. So you can say Michael, quotation mark is the name of Michael. You kind of mention the name Michael and say this relates to this person, Michael. And in philosophy, there are many ways of using quotation marks, but one of them is to indicate that we're moving to from talking about an object to talking about a name, or from talking about the world to talk about language. There's this famous Lincoln, according to Quine, whose views on quotation are fine. Boston names Boston, and Boston names Boston, but 9 doesn't designate 9. So you can add quotation marks to make sense of this funny poem. Okay, why is this related to logic? To what we're doing? Anyone has an idea?
Because
Yeah.
Well, because you're not using English as a language, you're referring to the language used in English.
Right. Yeah. Basically, what we're doing here is a lot of we have 2 languages now. We have kind of English, and we have the language of true functional logic. And sometimes I'm talking about the language of true functional logic. Sometimes I talk about the language of English. Sometimes talk about Tilburg being in the Netherlands. So it can be confusing sometimes. Another important distinction in logic is between an object language and a meta language. Meta language, cool name. But what does it mean? We're studying a language now, right? The true functional logic. So the language that we're studying, investigating, we will call the object language. The object language has signs like an arrow, and this and that, and parentheses. These are the language, the object language that we care about. We describe this language in English. So the language that we use to describe the object language is known as the meta language. English not being anything special, I could have, in a other possible situation, I could have taught this class in Dutch, right? So that then Dutch would have been the meta language. But true functional logic would have still been an object language. So back to the use mentioned, if you think about a sentence like Gras ist grün is a German sentence, this kind of doesn't make much sense in English because this expression is not in English, right? So you could argue that the red sentence is not a well-formed sentence in English. It's not a grammatical sentence. How do you make it into one? You specify that you mention the expression Gras ist grün with quotation mark, and then you can say it's a German sentence, and now it kind of becomes a sentence that makes sense. Okay, so this is how we use the quotation marks many times. And also to mention that we're talking about a bit of language. Okay, this time in German. So you can say here, German is my object language, and I'm using English to say something about that object language. But in logic, the object language is always this like weird squiggly sign stuff. And the meta language is English in our case. Okay? And the same thing happens when we talk about TFL. So you can say D is an atomic sense of TFL. That doesn't really make sense because D supposedly stands for some sentence, right? So you have to put quotation mark to make sense of that. You're saying, I'm talking about an object language in English, and I'm saying about something about it. But we don't use quotation marks in logic, okay? Because they always allow us to talk about a particular expression, right? When I'm saying quotation mark D is an atomic sense of TFL, it's true, but what if I want to say something about an arbitrary sentence of TFL? And we need that in order to talk about the object language in an arbitrary way. We need to have a way to talk about arbitrary formulas, arbitrary expressions. And so you've seen there are many like rules of grammar that apply to any arbitrary sentence. If you have two conjuncts and a conjunction, you should put a parenthesis. So how do you capture? So for another rule is if A is a sentence of TFL, then not A is a sentence. But what if you have not B? What about that? This is not an arbitrary sentence. This is a sentence of the object language. Okay. The way we resolve all these like linguistic conundrums is that we are just going to use the italic font in this course. Whenever I'm look at my amazing italic font here, whenever I'm using an italic font or a fancy font, then I'm kind of indicating that I'm talking about an arbitrary expression in terms of true functional logic. Okay. In other courses, you just sometimes in logic you just switch to Greek letters. You use like phi and psi, and then you're kind of indicating this is like an arbitrary sense. But this is not what we do here. Here we do use kind of like italic fancy fonts to indicate this is an arbitrary sentence. And note, now it's going back to Gras ist grün is not a sentence of English. The fancy A is not an expression of the object language of TFL. The object language of TFL is always made up of capital letters, connectives, and parentheses. So whenever you see this like fancy A, fancy B, then you know we're talking about true functional logic from the perspective of English. Okay? Yeah, question.
What's an arbitrary sentence?
So look at so an arbitrary sentence is just like I want to talk very, very generally about true functional logic. I want to say any sentence that you have in true functional logic, any arbitrary sentence, you can add a negation to it, for example. So you would say it as like, if A is an arbitrary sentence of true functional logic, then also not A is going to be a correct sentence of true functional logic. Okay, so this is kind of all boils down to understanding this like use of the fancy font and why do we use it. Okay, because it's very important in studying the logic, the object language, to know exactly what is a sentence of the object language and what is not. It will be very important going forward to understand other topics. Okay, so it's very important for you that you will be able to say this is the correct kind of like well-formed sentence in true functional logic, the same way that I can say something, try to say something in Dutch, and you can say this is not how you form a sentence in Dutch, right? You know how to form a sentence in Dutch or in English. You need to have the same ability when it comes to true functional logic. Questions? Okay, so what are the expressions of true functional logic? Now we can kind of get to it. There are three kinds of symbols. We have the atomic sentences, and again, not in the fancy font, just like regular ones. We have our 5 nice connectives that we studied, and we have the brackets, or so parentheses. So an expression of TFL is any strings of symbols and of these symbols. So this is going to be an expression as well. Okay? Because it's a string of symbols from TFL. But we don't care about every expression. We care about sentences. Only some expression will count as sentences of TFL. The same that I can take English words and create an expression like Michael has 3 nouns. This is not a sentence of English, right? But it's built out of English words. So we make a distinction between just arbitrary expressions and well-formed sentences. So what are the well-formed sentences in true functional logic? Exactly the individual atomic sentences, so like A, B. Further sentences formed out of these using the connectives, and that's it, nothing else. Okay, these will count as the sentences, and here we have the exact recipe of how do we build a sentence given the connectives. So, and this is where the fancy A and B's are put. So we say, what are sentences of TFL? Every atomic sentence is a sentence. So N is a sentence of TFL. And then I'm saying, if some arbitrary sentence A is already counts as a sentence, I can create another sentence by adding a negation. If I have 2 sentences A and B that I already decided they are well-formed sentences, then brackets A conjunction B brackets, close brackets, is going to be also well-formed sentences. So I'm kind of like giving you the recipe or the building blocks I'm giving you the base story, the atomic sentences, and I'm giving you the recipe how to build any other type of sentence. So this applies to all the connectives, and then nothing else is. And some cool logic words. This is a recursive definition because it kind of specifies what is the base case, the base element, which is the atomic sentences. And then it gives you a rule to generate infinitely many sentences given these rules by basically applying the rules again and again. Okay? If you're familiar with like other example in programming, you also have some recursive programs that kind of like reapply themselves until they hit some base condition. This is similar, but that's not important. What is important is that if we have a well-formed sentence, we know that it was built using these rules, so we can kind of decompose its structure according to the way it was built. Okay, for every sentence, you will either say this is an atomic sentence, or you can tell yourself, I got here by applying this rule and that rule and that rule and that rule until you reach atomic sentence. Let's look at a few examples. So how many negations do we have? 1, 2, 3, 4, 5, 6. So not Q. This is an expression of Q well. Is this a sentence? How do we approach this? And weird question. So you ask yourself, is not Q sentence? Five nots. How do I know? I need to go backward and say, not. Is that a sentence? I don't know. I need to go backwards until I get to Q. I know that Q is a sentence because it's an atomic sentence. And then I know, picture it. I know that Q is a sentence, and I know that not Q is a sentence, and I know that not Q is a sentence. Right, so I can reapply negations according to the rule for how to construct sentences until I get not 6 knots Q, which is a sentence. There's this joke about the Dutch logician that on his gravestone it says, not dead. Okay. There are a lot of Dutch logic history, which is very interesting. The Netherlands has a lot of history in logic. Okay, let's look at a harder example. Look at this ugly sentence over there at the top. I don't want to even read it, right? But what do I look? When I look at it, I see that what is the first symbol that we see? Not the negation. So let's look at the rules. If the first thing I see is negation, it means that in order to construct the sentence, we have to go through this stage, right? Stage 2. So I need to check that this part without a negation is a sentence. What was this constructed of? Which operator, which connective? Disjunction, right? I took a disjunction of P and this expression, and I put them together with the disjunction rule. Now this is a sentence, right? We know that P is a sentence. So we're good on this side. We need to still check that this is a sentence. How was this sub-sentence was created? With what rule?
Conjunction.
The rule for the conjunction, right? It was, you had not X and this expression, if not R then P, and I used the conjunction rule, rule 3, to get this sentence, right? Okay, and we know that X, now how was not X created? With the negation rule, so we get to X, X is a sentence, good. So we only need to check how was this created, what connective created this sentence?
Conditional.
The conditional, right? Together with not R and P. And now we know P is a sentence, and R is a sentence, so not R is a sentence. So we walked all the way down to all the atomic sentences, and we saw that we can build up this long expression at the top with our rules, and we didn't use anything else. Okay? Now, why is this cool? Or I think it's cool. This is kind of non-trivial because if you think about something like expression like this, could I build this expression from the rules I gave you?
No.
Okay, so let's see why. We look, okay, there's a negation, so it means that we build this expression. Let's suppose it's possible. We use the negation, so this means that if this is a sentence, then this is also a sentence, right? Okay, I moved from here to here by negation, but then I ask myself, can I create this expression with my rules? And you notice that the only way to get it biconditional is by applying two sentences. So I kind of showed, okay, this cannot be a sentence. Okay, the same way that when you learn Dutch or English, you learn that Michael has not, tree not, is not a, it's ungrammatical, right? Grade school, you will get like bad points on grammar if you write stuff like this. Okay. Questions about this? Okay, it's a matter of like realizing that everything should be built from these rules. Okay. So what do we know? If we break down any well-formed expression, a sentence, it will be we will hit rock bottom, so to speak, with atomic sentences. So every sentence is constructed out of atomic sentences. And either the sentence you have is just an atomic sentence, or it was built up with the rules. Now, if you have something which is like a sentence that involves connectives, there is always a connective that was used last, so to speak. Right? It was always a last step to get to our connective. The connective that was used last, or like the last rule that we use to get the final sentence, this is called the main logical operator, or the main logical connective. This is a very important concept when we move on to next lecture. Okay, the textbook gives you this definition of how to find a main logical operator. I think this is more confusing than helpful, so I think it's better to understand this in terms of like actually understanding how a formula was constructed. Okay, let's look at some examples. You have three similar sentences here, but the parentheses are somehow different. We say that something is the main logical operator if it is. This was the rule that was used last in order to get to that expression. Here, what is kind of the rule that was used last? How did I get the last expression? The conditional, right? I had this kind of A part and this is the B part, and I applied the conditional. So the conditional is the main logical connective or main logical operator of the sentence. What about this one? The second one. What rule did I use last to get there? The negation, correct. I had this expression and then I negated it to get to what I want. And here, the last one, what was the last rule being used? Disjunction, yeah. Okay. This is not necessary for this course, but I can show you kind of another way to think about it. So you can think about it as kind of like I'm constructing it as a tree, kind of like each time you said a disjunction was used here, a disjunction of what parts? The not P and the if Q then R, right? And then how did I construct this? Applying the rule of negation, so I get P. And how did I get this? Applying the rule of conditional using two atomic sentences. So you see how here, with this kind of tree that you can draw to yourself, how we build the entire formula. I have atomic sentences, here I apply negation, here I apply conditional, Then I have these two expressions, and I apply disjunction to get the last formula. Now the trees for the other expressions will look differently because the last step, this is the last step, use the different operator. Okay? So one thing you want to check for yourself that you understand how to recognize what is the main logical operator of a sentence. And a good thing is that if it's actually a sentence, for sure it has one unique main logical operator. Okay? Yeah?
In the last example, what was the main logical operator?
The disjunction. So if you think about it like in terms of this tree, this is the formula I have, right? And I ask myself, what was the last step? Combining not P and if Q then R. So, and I combine that with the disjunction. So it's going to be a disjunction. Okay? Okay. Now, remember we talked about the scope of a negation, and we kind of used, you can kind of use ways of like drawing the scope and understanding the negation can apply to the entire sentence and only to sub-sentence. So the scope goes together with this like rules of building, right? It's like the scope of any operator is completely determined by these rules. Basically, the scope of a connective is the sub-sentence for which that connective is the main logical operator. A lot of information, but again, look at this drawing here that I gave you. Can you all see this? Better? Okay, so I have a negation here, right? And I ask myself, what is the scope of this negation? So the one way to do it is to kind of draw this entire way of building the form, the sentence. And then I note here, what is the main logical operator? The operator or connective? Negation, right? So, and the negation only applies to P. So I know that the scope in the final sentence, the scope of the negation applies here. This is exactly what it means that the scope of the connective is the sub-sentence for which that connective is the main logical operator. The same for the implication. What is the scope of the implication? What does it connect, so to speak? Which part of this big sentence? We look at this like the way we form the sentence, and we know here what is the main connective, the implication, right? Conditional. So the conditional, the scope is these two sentences. Okay? Okay, why are brackets important? This is kind of all connected. Basically, without the brackets, we would not know how a sentence was formed. Look at these three sentences we have here. Without the parentheses, without the brackets, they all have the same structure, right? But we notice that with the brackets, we can tell which one of them, in which one, and what is the main logical operator. This means that when you see an expression like this, you're in trouble. Because you can ask yourself, what is the main logical operator here? And you don't know. Because you cannot tell what was the last rule that was used to get. And compare that again to here, where the parentheses kind of help you understand. I used the conditional with R and the expression and this expression to get there. Okay, this is why brackets are so important in true functional logic. They're kind of like act as our punctuation marks to read the sentence. Yeah?
So like in contradiction of mathematics, there are no hierarchy of connectors.
So I'm not sure what you mean hierarchy of connectors, but like,
Like when multiplication as a.
okay, precedence, yeah.
Minus in mathematics.
No, we don't think about it like this. The precedence, like which operator you read first, should be completely determined by the brackets and the rules of them. Yeah. Good point. Good point. Okay. For next time, we'll look at evaluating true functional logic senses, so giving them truth values, true or false. And this is where really we get into things. So please read the next chapter for all X, and you have here the questions for our assignments. I will stay here, or if you have questions about the syntax, the rules of grammar, good time to ask. Yeah, units are like the subset. These are the units. These are the units. In general, yeah, they help. Yeah. The way to think about it is connectors decide the brackets, and they decide the splits. Yeah.
Can you quickly put it on the next slide?